With lecture one and just introduction with respect to research. We have a little bit to talk about and we'll split it into 2 weeks. The purpose of today is to just give you an idea of what to expect in terms of research for this class, as well as some example topics that is related to aviation that you might want to consider or come up with a plan similar to it for your research topic and proposal. So let me begin. I've got two documents right here. On the left-hand side is the lecture one notes where we'll go over it over the next 2 weeks. And then also some example topics, and I've got down here some example papers that literature review-wise you'll have to be able to do as well, and how you make that plan accordingly. And so if we do an introduction to research, what is research and how does that entail to us? And so what we're doing is figuring out, okay, we have a problem in aviation. So what are some of the problems we might face in aviation? Well, to name some of them, fatigue. So looking at how fatigue affects performance in aviation. One potential topic, and it's been done in the past, is looking at various states of fatigue and measuring how performance or measuring the pilot's performance using some sort of simulator or some sort of measurement tool. So the definition of research in the sense of what we're talking about, we're not talking about just researching past papers and coming up with some paper that you post for your class. This is research that has some hands-on application to a problem. So it's the process of finding solutions to a problem after thorough study and analysis of the situational factors. So for example, back to my scenario of fatigue and pilot performance. So I'm looking at two variables, pilot fatigue and then performance, and how they are related to each other. And so the study would be to analyze a group and see if various levels of fatigue, so maybe you'll have one group of pilots have a good night's sleep, one group of pilots have only 5 hours of sleep, and one group of pilots who haven't slept in 24 hours. This is just a scenario example. And then you put those three groups and assess their performance in a given, let's say, instrument approach. And so we are finding what the situational factor is, and the situational factor is hours of sleep, level of sleep or rest, and then performance. And if we see that there's a degrade of performance with respect to fatigue, then we have a problem. And the solution would be that we make sure that there are measurements, or sorry, not measurements, but measures or ways to ensure that pilots aren't fatigued or are aware of their fatigue level and how that might affect performance. So we put measurements to ensure that it doesn't happen, that pilots don't fly while they're fatigued. That would be just an example. So there's a whole process of research that we want to solve. How is it different from just here's a question and here's an answer? Maybe some of the research topics you've done before where it's a question or a problem and you're just solving it using an answer. Well, what we do is we are systemic, so figuring out groups and how we're going to measure the problem or measure the analysis or factor. It's database, so really collecting data, analyzing that data, be critical of that data, and be able to propose findings and answers based off that data that you collected. So let's look at some common research items in aviation. I've got a couple different ones here. I talked about fatigue as one example, but another one would be potentially risk assessment or decision making. So an example for a research topic would be what's the decision making between different levels of flight students using an assessment tool, a risk assessment tool. So there's the flight risk assessment tool that's out there that a pilot scores their analysis of risk of a given flight scenario. And this particular problem statement that gives an example of research would be the purpose of the study is to examine which pilot group makes a better risk assessment, go-no decision, using the same risk assessment tool. And so this study is going to identify which group is willing to take more risk, and determine if there is a direct relationship between risk taking and the level of flight training experience. So the reason for doing that is to see if, which pilots are more at risk. Maybe maybe a insurance company might want to take this research topic and explore it, because then they can assign hours to risk level of a pilot. So this might be a way to determine which group or hour setting of pilots are higher risks based off some assessment tool, and measuring it from a groups of pilots, and running them through the scenario and collecting the data and seeing which group is better at assessing risk using that tool. So another research topic would be similar decision making within a specific pilot group. So looking at different pilot groups and using that same risk assessment tool. So those are some examples with respect to research in aviation. Another example that I can come up with is looking at a pilot, assessing the pilot's assessment of trust in automation. So let's say you have autopilot in the aircraft. How willing is the pilot to agree with the automation level based off their experience? So kind of looking at the difference between experience with respect to trust and automation. How much what factors play a role with how much that pilot trusts that automation? And so we have different types of research. You might hear of basic research versus applied research. And what we typically do in these sort of research examples that I've given you is basic research. We're kind of looking at generating a body of knowledge, finding out which factors affect decision making, for example. So like this topic that I have here is a example of basic research. Showing that, okay, if we collect this data, it may not be immediately used. It's theory development. It kind of helps you understand that, which pilot group is more of a risk in that sense, or decision-making risk, or which scenarios would cause one pilot to go versus another not to go. So that would be basic research. Applied research is something along the lines of any research that's the intention of using immediately to solve a current problem or issue. And some of these research topics that I talked about, like the fatigue one, or even this risk assessment tool, can have an element of applied research, because based off the results we'll determine whether we will use it for solutions or not. But really applied research applies to mostly things like Apple, so iPhone research, applied research. So, sitting in a lab and figuring out what next screen they're going to use would be applied research rather than basic research. So that's the example of basic research versus applied research. Basic research is mostly data-driven and data collection, whereas applied research is figuring out a solution to a problem using actual hardware and things like that. Whenever we do research, we want to involve ethics. So anytime you do research that involves behavioral analysis or using actual human beings or animals, anything along those lines, you have to follow a code of ethics with respect to research. And we have something called an institutional review board for any organization to review the research topic that they want to do, whether it's when it's using live data. So if you're going to collect behavioral analysis or surveys from 100 students at UAA, you'll need to go through something called an institutional review board to make sure that there's minimal risk, that will maintain confidentiality to the results, things like that. That's important for ethics. There's a term we say that data belongs to the data giver or data provider, which is very interesting to, with the current state of things in social media and Facebook and Instagram. There's a lot of laws and congressional hearings with respect to data and data confidentiality. But when we do research, we have to make sure that we pose minimal risk to the individuals that we utilize in the research project. Now, if we used what we call ex post facto research, or data, ex post facto data that already exists out there that's anonymized or is available to us to use, it's past data, so we're just looking at past data to solve a current problem. That doesn't really require institutional review board because you're not gathering live data, and then most of the time that's already anonymized data anyway. It's been de-identified in that sense. So ex post facto data, which I would probably be able to give you some of the ex post facto data for you to use as an example for your research topics that you come up with, would be something that we can do here. So scientific investigation, in terms of the scientific research, what are some of the things? I'm going to cover some of them, and then I'll leave it at the below from here. We'll stop. So I just want to cover the scientific research and the hallmarks of research to start off this course. So again, our purpose is to focus on problem solving. So we use a step-by-step, logical, organized, and rigorous method to identify a problem, identify the variables that we want. What are we actually measuring and what are we comparing it to? Are we comparing different pilot groups? Are we comparing different methodologies of flying, different means of instructing if you're a flight instructor, and how that affects another variable, performance in a student, the ability to complete a course or complete the materials accordingly. So that is what we mean by identifying the problems and the variables of that problem. And then we want to draw conclusions from them. So great, we identified the problem or the variables, and then we are now trying to assess what works the best in terms of the results. What would the results actually mean? So inferring, inferential data, basically. We're taking the data and inferring results, trying to infer conclusions from those results to come up with potential solutions based off that data. So what are some of the things we need to make sure we have in any research topic that we come up with? Well, first of all, purposiveness. What does that mean? What is the purpose? Why are we doing it? A lot of the times you might read a research topic and be like, what was the point in that? You really want your research to be purposeful in the sense that it is solving a problem that is current and makes sense. So addressing pilot fatigue or addressing automation. Actually, automation is probably the best one that's out there right now because there's a lot of human factors associated with that. How do we make sure that the pilot doesn't fight the automation? The example I can give is the 737 with the new systems that they came out with the stall recognition and fighting the pilot with the pilot was fighting basically the automation. So understanding that system, understanding how the pilot reacted to that system, and how can we mitigate that from happening again, whether it's through training, whether it's through just awareness, things like that. Better design, so that's just things to think about. Rigor, good foundation, consider all outcomes, cover your bases. So what does that mean? So in terms of rigor, a good foundation would be, is it based on a theory, an actual theory that's out there that exists and makes sense? For example, is it based on the theory of trust and automation that's already out there and levels of trust? Is it based on previous research that already has data collected and an analysis associated with it with results? So is there previous research associated with it, and are you able to replicate it? And then testability. Are you actually able to examine what you want to examine? Are you able to measure one of the variables? So are you able to measure performance of a pilot when they're fatigued, you know? You have to be clear as to what's measurable and what's testable. So um, uh, measuring, for example, a variable like fatigue with respect to, let's see here, happiness. For some, I'm just giving an example. Level of pilot fatigue with level of pilot happiness. That's so broad and so unclear that how am I supposed to measure that? So that's not really a testable, nor is it really purposeful. It could be purposeful. I could argue that aviation managers might want to know how employee satisfaction might play a role. But it's not really very testable. So those are things that you have to consider. Is it something you can use a ruler to, in the sense that are you able to really measure it accurately and produce results accordingly? Are you able to replicate it? Are you able to rerun the experiment and produce the same results if you had to rerun it? So if it's not replicable, it's not valid. Is there precision and confidence associated with it? Are your results kind of close to reality, or are they completely off? You know, if you're trying to test, for example, back to the fatigue versus performance, and you find for some reason your results show that the more tired a pilot is, if they've barely slept, they perform superbly. Does that really make sense? Is there a confidence level? Is there a confidence with your results that your estimation of your results are correct? You're never going to get 100% confidence with respect to a result. There's always going to be a 0.05% error or a level of error to some degree. Even with medical results, you know, they always say there's a chance of X, Y, and Z because their confidence levels are not always going to be 100%. There's never really, with human behavior, 100% confidence. Objectivity, are you based on facts, or are you just making it up, or just choosing random variables to you know, analyze and find results with? Are you able to generalize? Are your findings going to be toward a bigger picture? And you know, can you say, for example, this risk assessment between private instrument and commercial students? If I select 100 of each, or no, let's say 20 of each group, 20 private students, 20 instrument, 20 commercial students at University of Alaska, am I able to generalize that to the bigger picture? Am I able to say all private, well, I can't really say that, but like majority of private students or private pilots, instrument pilots and commercial pilots will react this way because of this data? So how generalizable is your result? And that's dependent on your sample size and dependent on your population that you're looking at. And parsimony. What is it meaning? Is it meaningful, and is it able to be elaborated on? Or sorry, is it meaningful and efficient instead of being elaborate and cumbersome? Does the results make sense in the sense that it really will produce meaningful outcomes? So that's the introduction to this course. What I'd like you to think over the week is a couple different research topics. So I'm going to post a discussion board where I'd like you to post a topic, a research topic of interest that could be used for this class. You know, is it, for example, that risk assessment between two groups, right? So between a group and then a tool, fatigue versus performance, stress versus decision making. So trying to look at two different variables and how you're going to find a problem and then potential solutions to it. So the goal is to kind of get our gears going with respect to research in aviation. Hopefully this helps, and we'll continue on with the material for week 2 later down the line.